Yo. Let me see if I can add a text. Okay, this I'll fix up later. We'll get rid of it. Am I there? Alright, so we'll do 20 problems. Probably 10 minutes per problem, so that means around 200 minutes. So we are in for close to 3 hours here. Let's start with the filters. We'll want to do problems that we haven't done. We are selecting easy problems, and the language is Java, and we start with a random problem. Hopefully these 20 problems gives me sufficient practice before, and then I'll continue to do it for maybe few more days so that we can then move to medium problems. But I think this should be a good starting point. So we are doing problem number 1. You are given a string. The score of a string is defined as the sum of the absolute difference between the ASCII values of adjacent characters. Return the score of S. So you are given a string S. The score of a string is defined as the sum of the absolute difference between the ASCII values of adjacent characters. Fair. Return the score of S. So for HELLO, difference between H and E, F, G, H, right? And then difference between, yeah, whatever score is 104 minus 101 plus this minus this plus this minus this, something like that, right? So I think I can do it like this. For equals to 1, I is less than S dot length I plus plus int score equals to 0, score equals to score plus, convert it into int. But what are you taking? You're taking s dot caret I minus s dot caret j. You do, sorry, not I and I minus 1. You get some difference and convert it into integer. Then you do math dot absolute of that. Okay, and then you return this code. Submit. Alright, so we're done with problem number 1. Move on to problem number 2. Problem number 2. First bad version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions 1 till n and you want to find out the first bad one which causes all of the following ones to be bad. You are given an API bool is bad version which returns whether version is bad or not. Implement a function to find the first bad version. You should minimize the number of calls to the API. Minimize the number of calls to what API? This is the API, right? This is what I have to implement. Okay, Is bad version API is defined in the parent class version control. Boolean is bad version int version. Let's understand. Do I have to implement this, or do I first, is bad version is an API? Okay, I got it. So obviously you can do a linear call, and the question would be, can I do it better, right? So, and the answer to that would be, you can, by doing like a binary search, I feel like. So let's do binary search. Okay, so how do we do binary search? You're given n elements, you will start with n by 2. So you go on the middle element. Now um, so now if is made bad, so what do you do if middle is bad? Could it be that nobody is bad? No, at least somebody would be bad. Yeah, okay. If this is bad, then this is what you do. Should I do while left as an equal to right, something like that? Yeah, let's do that. Why not? And if it's not, what if it's not bad? Okay, if mid is not bad, that means it's in the right of it. So L equals to R plus 1. Mid plus 1, my bad. And that's it. You'll find some bad, no? So you can keep this as -1 also. Let's see. It is working, at least for the 2 test cases, and it does work. So we do it in linear time, sorry, in linear arithmetic or logarithmic time. Okay, next problem. This is problem number 3. Make array 0 by subtracting equal amounts. You are given a non-negative integer array nums. In one operation, you must choose a positive integer x. such that x is less than or equal to the smallest non-zero element in nums. Subtract x from every positive element in nums. Return the minimum number of operations to make every element in nums equal to 0. 15035. Output is 3. In the first operation, choose x equals to 1. Why choose x equals to 1 is the question. Choose a positive integer x is that x is less than or equal to the smallest non-zero element. Yeah, the smallest non-zero element is 1. So you can choose x equals to 1 and then you can make it 0. Subtract x from every positive integer. Okay, so I subtract 1 from everybody. Okay, so fine. Now whatever is left, now 2 is what I choose, right? And I subtract 2 from everybody. And then I choose 2 again and I make it 0. Okay. Interesting. But isn't it like what do you say? Let's look at another example. Nums equals to 0. Each element in nums is equal already 0, so no operations are needed. Yeah, that's fine. Let's look at this problem again. It says I need number of operations equals to 3. I think the value does matter. Here the values are 1, 3 and 5. Okay, so 1 to become 0 it will take 1, then the 3 will become 2, for it to become 0 it will become 2, and then for 5 it will take 1 plus 2. I think you have to take the non-zero elements. Is it all positive? Yeah, okay, so you have to take, like, I feel like you have to sort the array and you have to keep the non-duplicate elements, and then the number of operations. So basically the number of operations, like if I consider this array, it's essentially 1, 3 and 5. That is this array for me. For 5 to become to equal to 3, the difference is 2, so it will take 2 operations for 5 to become equal to 3 or not. So 1 minus 3 is 2. No, this one has to play a role. But okay, whatever you are subtracting, you just keep the count of it, no? So now you're subtracting 1 from everybody, and then when you come to this number, this is not equal to 1, this is equal to 3. So when you subtract 3, the difference is 2. So that means now you add that difference, which is 2. So now you're subtracting 3. Not carrying it. Okay, so one. Okay, when I'm here, this is what I say. Then when I do this, difference is 2. So now I'm going to subtract 2 from everything. So I'll add 2 to it. So this will become 3. I'll subtract 3 from everything. So this will become 0. This is the second operation. Now I come to 5. The difference is 2. It's not equal to 3. So now this becomes 5. And I'm going to subtract 5. And this is the operation number 3. Something like this. Okay, let's try to see if this makes sense to me. Then I can also sort the array. Yeah, you can. So arrays dot sort nums int diff equals to 0, ops equals to 0, I equals to 0, I is less than nums dot length I plus plus. If nums of I is less than 0, less than or equals to 0, just nothing, right? Nothing is do nothing. Else if I is not equal to 0 and nums of I is equals to nums of I minus 1, even that do I need? I think all you need is I mean this is even not required, I guess, because they start from 0 at least. So, and diff is also 0. Nums of I minus diff, if this is greater than 0, then you have to do ops plus plus and diff plus diff equals to diff plus nums of I minus diff. Is that the right thing? Then doesn't the diff just becomes equals to nums of I? It does. So which is what was exactly happening. So what that essentially means is number of unique elements, no, in the array. It's literally that. It's a very weird one, but let's see. Okay, it does work. Great. You could have even used as oh, you did a sorting here. Now I'm gonna say you could avoid sorting because it looks like it's just a unique number of elements in the array in a weird way. Because where am I from? I'm from India. Make array 0 by subtracting equal amounts. You are given non-negative. Okay, I think what I'm saying is, let's take some random example, yeah, which is 1, 6, 8 and 9. Let's say this is an example, right? So I'll subtract 1 from everybody, so it will become 0, 5. Essentially I'll be left with 5, 7 and 8. So I'll subtract 5 from everybody, so this will go away this will become 2, and this will become 3. Subtract 2 from everybody, then yeah, it's just unique number of elements. It's just a stupid thing. It's just unique number of elements. So we did one way by sorting, which was n log n time complexity. Even that worked fine, but there's a better way, which is how about this? Does this work also work? And submit. And this one works as well. Alright, let's move to the next problem. A self-dividing number is a number that is divisible by every digit it contains. For example, 128 is a self-dividing number because 128 is divisible by 1, is divisible by 2, is divisible by 8. Okay, a self-dividing number is not allowed to contain the digit 0 because it can't be divided by 0. Makes sense. Given two numbers left and right, return a list of all the self-dividing numbers in the range left to right, both inclusive. Okay, 1 to 22. 1, 2, 3, 4, 5. I mean, from 1 till 9, no problem. 10 can't be. 11. What digits are 1? 12. Is it divisible by 1 and 2? Man, it's a hard problem, no? One and 5, 2 and 2. Interesting. I mean, let's do brute force. Okay, what is the range of left and right? Can be 10 to the power 4. So this is my brute force. I'm gonna definitely look at the editorial here, because I'm sure there must be some easier ways or some optimization possible. It does look good, but let's still look at the editorial. Brute force is accepted. For each number in the range, we will directly test if that number is self-dividing, which is what I did. Okay, that's the only thing it's given to us. Fine. Then this was problem number 4. Let's move to problem number 5. A number after a double reversal. Reversing an integer means to reverse all its digits. Excuse me. Sorry about that. A number after a double reversal. Reversing an integer means to reverse all its digits. For example, reversing 2021 gives 1202. Reversing 12300 will give 00321, which is equal to 321 because leading zeros are not retained. Given an integer num, reverse num to get reversed 1. Then reverse reversed 1 to get reversed 2. Return true if reverse 2 equals num. Otherwise returns false. So 526, 625, 526, it will be true. And then other one is 1800, it will be 18, 18 will be 81, so it won't be. So if you have trailing zeros, if you have even one trailing zero and that's sufficient, then it won't be. So I can say this, which is return num percentile 10 is not equal to 0. Does this work? It says no, it's wrong. Okay, but maybe except for this one case. Except probably for this one case. See? Alright, problem number 6. Check if array is good. You are given an integer array nums. We consider an array good if a permutation of an array, if it's a permutation of an array base n. Base n equals to 1 till n. In other words, if it is an array of length n plus 1 which contains 1 to n minus 1. What? Wait, base n is 1 till n and an extra n? In other words, it is an array of length n plus 1 which contains 1 to n minus 1, exactly once, plus 2 occurrences of n. For example, base 1 equals to 1. What? Okay, base 3 means 1 to 2 and then 3 will occur twice. Okay, return true if an array is good, otherwise returns false. 1 2 3, yeah. 1 2 3 3, yeah. It's a boring problem, no? I mean, it's no. Okay, so I got the sense of it. Is it a guarantee that nothing is a guarantee? I mean, because nums of i's guarantee is not there. Can I do XOR? Can I do XOR throughout? I don't know, but okay. One option is obviously I use SAT, or rather a map. I think I can do with without a map as well. I can do some in-place adjustments. Okay, let's see what in-place adjustments you can do. I equals to 0, I less than num start length, I plus plus. So the first thing is we have to get val. So I now if this val is greater than, let's get the value of n as well, right? So for example, for n equals to 3, it will be 1 2 3 3. The length will be 4. So n is length minus 1. This is n. Okay, so if you find a value, if value is less than 1 or value is greater than n, you can just return false. Now I can also do and I will also do one more thing. No, I won't do, this is fine. Okay, let's see. The value that I will get will be 1 2 3 4 till n. So 1 till 1 till n, and the indexes will be, because the length is n plus 1, indexes will be 0 to n, right? So I don't even need to do minus 1. So if I say if nums of val is less than 0, that means I've already marked it negative. I mean, this is given that it's positive only, right? Yeah, it's positive only. So if I mark negative, that means it's a double occurrence, right? Double occurrence is only allowed for one thing. This is also a problem, right? You could have same number occurring multiple times, who knows. So this is if it's already negative. So you've done this. Now what do you want? So what I want is, now just think about this. If I go through every element, if they were not in the range or if they were not found, then something else would have happened. So basically what I'm saying is you have to return true. You don't have to validate again. Otherwise this would have happened, right? One of the two return false would have happened, this or this. Alrighty, brilliant. This was problem number 6. Hey, what's up? What are you trying to make? I'm not trying to make anything, bro. I'm just solving some problems. I'm trying to solve 20 problems. I'm on problem number 7. Make array elements equal to 0. You are given an integer array nums. Start by selecting, okay, make array elements equal to 0, fine. You are given an integer array nums. Start by selecting a starting position current. Given integer array nums. Start by selecting a starting position current such that nums of current equals to 0, equals to 0, and choose a movement direction of either left or right. After that you repeat the following process. If current is out of the range 0 to n minus 1, this process ends. It's too big. If nums of current is equal to 0, move in the current direction by, if current is out of the range 0 to n minus 1, index is out of the range, then process ends, fine. And if the value of the index is 0, move in the current direction by incrementing current if you are moving in the right, or fine. Otherwise, if the value is greater than 0, you decrement it by 1, reverse your movement direction, take a step in your new direction. Selection of the initial position current movement is considered valid if every element in the nums becomes 0 by the end of the process. What the fuck? Return the number of possible valid selections. My goodness. Yeah, I responded, Ajay. I'm just solving problems. That's it. There might be some delay, so, but that's okay. Nums equals to 10203. The only possible valid selections are the following. Oh man, this is tricky. How do I solve this? It says choose current equals to 3 and a movement in the direction to the left. Okay, so 0, 1, 2, 3. You start from this 0 or this 0. One of the two zeros you start with. I start with this 0. And again, I have to choose a direction as well, right? You can choose any direction. Okay, you choose a direction. It says movement to the left and a movement direction to the left. Okay, so I choose 0. And then what direction is left? So I am at 2, and then 2 is greater than 0, so decrement it by 1. So I reduce it by 1 and I change the direction I decrement it by 1. I change my direction. I come back to here. Take a step here. I am here. Then I take one step further. 3. Change it to 2. My goodness. I don't know how to solve this. Brother Ajay, you can see this is Java. It's written here. Hopefully you can see it. Okay. Choose current equals to 3 and a movement direction to the right. So you could do it from left or right. I don't think I'm able to solve this problem. Okay. There is at least one element I when num psi equals to 0. All this is fine. Basically what I'm doing is I'm reducing the values by 1 always, right? And I can move so whichever 0. Okay, so now look at this again. For this 0, on the left there is 3, total sum is 3. On the right there is total sum is 3. For this 0, on the left it's 1, on the right it's 5, so it's tricky, I guess. I think it's possibly just that. So for this 0, 9 and 5, so nothing is possible. So basically I'm thinking with all of this approach and whatnot, could it be just like what is the sum to the left of the 0 and what is the sum to the right of the 0, and if they are equal then it works out, because that's what is happening for this 0, right? You make it 2, then you make this guy 1, whatever, then you make this 2 to 1, then you make this 1 to 0, then you make this 1 to 0, then you make this 1 to 0. Or they can differ by 1, right? They can differ by 1 as well. Like, so for example, let's say it was 403 and let's say it was 304 and then 303. Let's solve one by one. So for this, make it 2, then make it 2, then make it 1, then make it 1, then make it 0, then make it 0. Alright, let's look at this. If this is the case, then you have both outcomes possible. If this is the case, then you have only one outcome possible. Like if and we have to figure out which outcome is the possible one. So for example, if I start from 4, becomes 3, this becomes 2, this becomes 2, this becomes 1, this becomes 1, this becomes 0, and then am I stuck or not? So now if this is 0, okay, let's make it simple. Let's make it 201. Yeah, 201. So if I start with 0 and I choose the right direction, if I start with 0 and I choose the right direction, choose a movement direction of either left or right. Let's say I choose right direction. If the value is 0, it's not. If the value is greater than 0, decrement it by 1, so this becomes 0. Reverse your movement direction, take a step in your new direction, then I have to go here, this will become 1, reverse my direction, and then I'm stuck. Yeah, so this didn't work. So for with 2 0 1, taking right direction did not work. What if you look at it the left direction? So left direction becomes 1, it goes to 0, it once becomes 1, it becomes 0, changes direction, move forward, becomes 0. Yeah, I got it. I got it, baby. Okay, so I think the answer is, for every 0, you need to find the sum on the left and sum to the right. And then, if the sum to the left and sum to the right are equal, then you have 2, then you count it as 2. If the sum to the left and sum to the right have a difference of 1, then you count it as 1, otherwise you count it as 0. Okay, so how do I get sum to the left and sum to the right? I guess you can have two cumulative arrays. So what is to the left of 0? There is nothing to the left of 0. Okay, right, this is fair. Right, and then you do right sum of nums of length minus 1 equals to 0 only. Okay, this is the right sum. Now brother, I will use Java only. If you don't like Java, I am sorry. This is our problem number 7. I suggest you look at the approach, or the whatever you want to call it, the algorithm or the problem solving, rather than the specifics of the language, because language is quite easy to understand. I'm pretty used to Java, so I continue to use to Java. I equals 0, L is an uncertain length, I plus plus. What I was trying to do? Yeah, I was trying to see if the number is 0. So if the number is indeed 0, then if left sum of I equals to um, right sum of I. If this is the case, then you can choose two valid options to choose. Then uh, you have to return valid, right? So 0 valid plus equals to 2, else if left sum of I minus right sum of I equals to 1, or left sum of I minus right sum of I equals to minus 1. In either of the case, valid plus plus, and then you do return valid. Let us see if it passes for our test cases. It does. But was our understanding of the problem right? It was. Great. We move on to problem number 8. So now we are on problem number 8. Categorize box according to criteria. Given 4 integers, length, width, height and mass representing the dimensions and mass of a box respectively, return a string representing the category of the box. The box is bulky. Okay, we are given length, width, height and mass of the box. We have to return the category of the box, and the categories are bulky if any of the dimension of the box is greater than or equal to 10 to the power 4, or the volume of the box is greater than or equal to 10 to the power 9 for here. If the mass of the box is greater than or equal to 100, it is heavy. If the box is both bulky and heavy, then its category is both. If the box is neither bulky or heavy, its category is neither and water. Okay, so let's do this. Length, width, height and mass. You get your bulky, and then you get heavy as well. Length, width, height and mass. So this is your heavy. Now if both are true, then return both. If it's not bulky and it's not heavy as well, then you return neither. Else if it's bulky you return bulky, and the last case is that it's heavy. And now let's implement both bulky and heavy. I think heavy is easy, so let's do heavy first. Now let's do bulky. Now 10 to the power 9, does it fit into an integer? I'm not sure. I think let's make it double. Yeah. Is it double or is it long? I think it's long. Alright, let's run. This is our problem number 8. Submit. And you get wrong answer for some cases. For 2 cases, these are 2 edge cases, I guess. You return heavy, but answer is both. You should have passed, no? Which? Oh, the mass. What is the mass? Mass is 1000. So you are returning heavy, but why did it not pass your bulky category? Was it? Yeah, okay. I think it's then the problem is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it even bigger than? I don't know. I don't get it. Equal to? I may say equal to. Is it? Oh yeah, it was just that. Okay. Move on to problem number 9. Remove linked list elements. Given the head of a linked list and an integer val, remove all the nodes of the linked list and an integer val. Remove all the nodes of the linked list that has node.val equals to val and return the new head. So in this linked list we have to return all the elements whose value is equals to val and then return the new head. Okay. So I have to remove it. Okay, I do have to remove it. Yes. So one thing is, if previous is null, what do you do then? Just remove it. New head is current.next. Previous will remain null. and what? If that's not the case, then this. And in all cases, current will move to current.next, right? So let's say there was 666. Oh, there was 666. Interesting. So then you should start with new head as null, no? Now new head with head. So 666. You start with 6, you remove, so new head equals to the next 6. Then you remove the 6, new head equals to this 6. You remove the 6, new head equals to null. So new head will become null. That way. And then you go and you return new head. I think I'm missing something here. It is missing previous. So in this case the previous is fine. In this case you have to set the, I mean in both cases you have to set the previous as current, don't you think? Not in both cases. If you're removing it then you don't. So you're saying else okay, let's run. And this is problem number 9, I believe. Submit, and it works. Let's move to problem number 10. I thought of doing 20 but I'm tired at 10, but I will do 20 today no matter what. Longest strictly increasing or strictly decreasing subarray. Strictly increasing or strictly decreasing subarray. You are given an array of integers nums. Return the length of the longest subarray of nums which is either strictly increasing or strictly decreasing. Given an array of integers nums, return the length of the longest subarray of nums which is either strictly increasing or strictly decreasing. But it has to be a subarray, right? So 1 4 is strictly increasing. That's it. Okay. 3. So subarray, you start with 1, you go to 4, it's increasing. From 4 it goes to 3, which is less than 3. I guess you have to go with windows, right? So with 1 you increase the window to 4. From 4 when you go to 3 it becomes a problem. So you see if it can be strictly increasing or not. Given that it's not, you have to, if you have current number, then you have to go to the last element directly. Okay, so 1 to 4 was strictly increasing. Now 4 to 3 is strictly decreasing. 3 to 3 is nothing. So you move to this element 3. 3 to 2 is also strictly decreasing. Okay. If nums dot length is equals to 0, you return 0. otherwise you will at least have one. Then the window breaks. Okay, so if it is equal to this, then what happens? Okay, if it is equal, then whatever your last window was, you get that and you break it. Okay, it's breaking, so then you do and you start with what? L equals to I and R equals to I. That is one case. Alright, other thing is it can be greater. If it's greater, then you have to see ki is it part of a longer subarray, or if the last subarray is just a single one. And if that's not the case, that means either L or R is not equal. That means it's already a decreasing array and it's not increasing. So for the decreasing array, now you're increasing or you're equal. Then again you do the same things. Alright, does this work? I think I'll stop here. I must stop here. I'm tired. Case number 3. 3, 2, 1. We returned 3 as the answer, and what did we return? Just 1. Okay, so there is this one bit that you're missing out on, which is okay, let's do this. And submit. We got some wrong answers. We got many wrong answers rather. One, 5, 2 and 7. So 1, 5, I understand. Let's come here and let's see what is. What was this? Standard out was 2, but then we returned 3. What that means is we did this r minus l plus 1, and that was a problem. The last window didn't work out correctly. But how is that possible? Yeah. So let's understand what happens. 1, 5, 2 and 7. 1, 5, 2, 7. Let's do 1, 5, 2, 7. L and R ball on 0. We start with L I equals to 1. Nums of I is not equal to sums of I minus 1. So you compare 1 and 5. They are not equal. They are increasing. So you make L equals to 0, R equals to 1, increasing equals to 2, and then it's not equal, it's not greater, it's lesser. So you come here and R are equal, no. And if decreasing equals to true, no it's not. So you go into this else, you will see greater will become 2, and then you will make L equals to I minus, so 5 and 2, right? L equals to 1, R equals to 2. Okay, 5 2 and decreasing equals to 2. So what you can do, 2 so 5 2 happens, 2 7 happens. So from 5 2 you get to 2 7. So for 2 7, so then it has to be a 2 and 7 only, right? Increasing in 2 and 7. Yeah, let's see. Let's also print L and R. Okay, so it's at 1 and 3. 0 1 2 3. L was at 1. How is that possible? L would be at 1 when you reached here, right? Because L is equals to I minus 1 or whatever. which is fine. Then when you come to 7 is greater, but increasing is not true, so it will come here. It will do whatever, and then it will say L equals to n minus 1. So they did not do that. I would really want to do a debug here. Let's do a walkthrough. Yeah, 1527. 1527. L equals to 0, R equals to 0. I think I'm getting some problem. I understanding some problem. When you said increasing as true, you should also set decreasing as false, and same other way around. Otherwise it's a problem. Yeah, and you should have kept a single flag, I guess. Yeah, now let's try and keep a single flag. It's not possible to keep a single flag, I'm sorry. It's 3 states, so let's use it. Let's use a 3 states then. Okay, let's run. It won't compile. It will complain about several things, but yeah, whatever. Line number 40. Okay, submit. Alrighty, good night, Shabakar, and whatever. Didn't pass that much, but the time complexity is clearly O of n. I mean, whatever you do, it's O of n. It's beautiful O of n. Alright.